Math 3, Practice 2A.3.4, the rational root theorem. So, still dealing with finding those x-intercepts, those roots, those zeros. And we have a theorem to help us understand what some of the possibilities are. Okay? So, in these first four, it wants us to use this theorem to list all the possible rational roots. So, we're not actually finding what they are, we're just listing the possibilities. And to do that, we have this rational root theorem. Okay? Basically tells us this. That we can take the factors of the constant term, so these would be the constant terms, and their factors, and we put that on the top of the fraction, and then Q, the denominator, the bottom of the fraction, is the factor of the leading coefficient. So in this case, 1, 1, 4, or 2. So those factors as fractions give us all the possible roots, okay? They give us all the possible roots. Alright, so let's take a look at them. So, what you do is you take the two factors, or the coefficient, and find all its factors. In this case, just 1. Then we take the, can't think of the word, constant, find its factors, which are 1 and 5. Okay? Then we make a fraction of them. And the numerator, the top, is the factor of the constant term, and the coefficient is the denominator. Okay, so this is the top, this is the bottom of the fraction. So we have either 1 over 1 or 5 over 1, which we'd simplify to 1 and 5. So looking at these rational, now we're not talking about the irrational or the imaginary, okay, just the rational roots. Could be 1 and 5, okay. Now, let's hurry and see a graph of this and see what they actually are. Alright, so here's that is graphed, and notice we didn't get either one of our answers of 1 or 5, which means we don't have any rational roots in this one. We actually end up having one irrational, that fraction there, okay, is an irrational root, and then we'll have two imaginary roots. So this is only good for giving you an idea. It's not very helpful, honestly, because it doesn't tell us exactly what we need to know. But this is how we find it. Okay? So let's do the next one. So number 2. So I take this negative 9, and we go through all the factors of negative 9. And one thing I forgot to mention, that we're pretty much thinking of all the positive and negative versions of them. Okay, so we think in terms of positive and negative. Okay, so 9 can be 1, 9, or 3, right? 3 times 3 is 9. And 1 would be 1. So we have 1 over 1, 9 over 1, and 3 over 1. So in other words, 1, 3, and 9. Positive or negative versions of them. Okay, so let's see if any of these are right. Let's graph this one now. So, anyway, I took a look at all these graphs, and all these graphs, 1 through 4, they don't have any rational roots. Which is fine, because all we're doing is putting the possible rational roots. So anyway, let's finish the last two. So factors of negative 1 would be positive or negative 1. Factors of 4 be 1, 2, or 4. So we'd end up with 1 over 1 plus or minus 1/2 or 1/4. So 1, positive or negative 1/2, and positive or negative 1/4. Those are our possible rational roots. Okay. On number 4, we have 12. Factors of 12 would be 1 and 12, 3 and 2. 2 and 6, and 3 and 4. Okay. Factors of 2 would be 1 and 2. So, this one has a lot more, right? So we could go 1 over 1, 1 over 2, 2 over 1, 2 over 2, 3 over 1, 3 over 2, 4 over 1, 4 over 2, 6 over 1, 6 over 2, 12 over 1, or 12 over 2. And then we'd simplify those. So that would be 1, 1/2, 2, 1 again, 6, 3, 12, 6, 3, 3/2, or 1.5, 4, and 2. So all those that are, already have them. So we've got 1 already. We've got 1/2. We've got 2. We've got 3/2. We've got 3. We've got 4, 6, and 12. So those are all our possible rational roots here. Then what we'd end up doing if we really wanted to find the roots would be to use the synthetic division till we found one and use that to simplify. Okay. Now I don't think that's the best way to do things. Okay, so let's look at 5, 6, 7, and 8. Now here they actually want us to solve these ones. Sorry about that, Belle. But they want us to find the solutions, the x-intercepts to these. Okay. So what we could do, what we I guess should do ideally, is we should find all the possible roots. Okay. So this is how we'd normally do it. Okay. So we got negative 21. So we've got 1 and 21, 3 and 7, and we've got 2, so 1 and 2. So we'd go 1 over 1, 1 over 2, 3 over 1, 3 over 2, 7 over 1, 7 over 2, 21 over 1, and 21 over 2. Then we'd simplify, so we've got 1, 1/2, 3, 3/2, 7, 7/2, then 21 and 21/2. Okay. So those, and positive or negative, I should say. Positive or negative on all of those, okay? And so on. Then we would start out and we'd start using synthetic division to see which ones actually work. So then using synthetic division, we try out positive one first. So we'd have 2, 11, 8, negative 21. Bring down the 2, multiply 1 by 2, bring it up here, we get 2, add 13. 1 times 13 is 13. Add those. That would give us 21. 1 times 21 gives us 21. Add those and we get 0. So that tells us positive 1 is a root. Okay. Then we'd go through and check all of these. Then once we found the roots, then we could simplify as needed. Okay. That's a lot of extra work. I would suggest we start by graphing. Okay. Because if we graph this one, okay, remember that fundamental theorem of algebra tells us we're going to have 3 roots, right? Well, we've got 3 roots. Positive 1, negative 3, negative 3.5. Okay? If we would look, there's positive 1, negative 3, negative 3.5. So they all show up there. And that's the whole point of that. But graphing it is much easier than trying to go through that synthetic division and deal with all that stuff. So we end up with x equals 1, negative 3, and negative 3.5. So my suggestion would be that we just graph all of these first, and then we can use synthetic division if we need to make it easier. Okay? So let's take a look at our next graph. Okay. So this is x cubed plus 3x squared plus 3x plus 9. So we do that one, and we notice we have one rational root, negative 3. Okay? So we know that x equals negative 3. Now what we can do is now we can use synthetic division to help simplify this. Okay? And then we can use quadratic formula most likely because we know the rest are going to be imaginary. Okay, so bring down the 1, negative 3. Add those together, we get 0. Negative 3 times 0 is 0. Add that, we get 3. Negative 3 times 3 is negative 9. Add those, we get 0, which is what we expected. So because it was cubed, this next one is x squared, so we get 1x squared plus 0x plus 3, okay, equals 0. So we can eliminate that, so we get x squared plus 3. Now to solve this, we subtract by 3, so x squared equals negative 3. Take the square root, and we basically get the square root of 3i. Okay, so square root of negative 3 and negative square root of negative 3. Or whatever the square root of negative 3, which is decimal. So it would be plus or minus square root of 3 times I, because it's imaginary. Okay, much easier process to use, I think, and we'll have that graphing calculator with us all the time, so we might as well do it. So now let's take a look at number 7. X cubed minus 9x squared plus 22x minus 10 equals 0. So graph it. Let's get rid of this. So here we go. So as we can see, we've got one rational. These two are going to be irrational. Okay, and I'll show you how that would work. Okay, but those are our three roots basically. Okay, now this decimal works fine to use, but sometimes you won't have it in decimal format. So let's go through the process again. So we know 1x is 5, so we can use that in synthetic division to help us out here. Bring down the 1, we get 5, add that, negative 4, negative 20, add it, 2, we get 10, add it, and we get 0. So we have 1x squared minus 4x plus 2. Now we could try to factor that using the area model, but let's just skip to the chase and use the quadratic formula. So the opposite of b being negative 4, plus or minus square root of b squared, negative 4 squared, minus 4 times a times c over 2 times a. Okay, then we simplify. This becomes positive 4, right? Negative 4 squared becomes positive 16 minus 4 times 2 times 1 is 8 over 2 times 1, which is just 2. Okay, so that was 4. Then 16 minus 8, well, that's 8. Okay, can we simplify 8? Yeah, 8 is like 2 times 4, right? Do we know the square root of 4? We do, it's 2, so that would pull a 2 out. We'd have 4 plus or minus 2 square roots of 2 over 2. Well, 4 we know is like 2 times 2, so I can eliminate 1, 2. And then I'm left with 2 plus or minus the square root of 2. So 2 plus the square root of 2, and then 2 minus the square root of 2. Now, if I go 2 minus the square root of 2, I'll get that. 2 plus the square root of 2, I'll get that. Same thing. Okay, same thing. Same thing. It's just a lot of time the answers will look like this, but if you were to type that into your calculator, you would end up with the same thing. And so you would be able to recognize that it's that one. Okay? Alright, so now if we look at number 8, we've got to the 4th power, right? So when we go to the 4th power, that means we're going to have up to 4 roots. So they could all be imaginary, because remember, imaginary comes in pairs. But let's graph it first. So we graph it, and we see that it crosses 4 times, right? 1, 2, 3, 4. These are the same graphs, it's just to get all the exact numbers. Okay? So our roots would be negative 1, 3, 0.805, and negative 0.138. Those two are going to be irrational. Okay, which means if we wanted to, we could go into this process of finding it. And I can show you really quick what it would look like. Basically what you'd end up doing, because this is to the 4th power, we start out with synthetic division. It doesn't matter which root we choose. Okay, bring down the 9, get negative 9 when we multiply, add it, negative 33, negative 1 times at positive 33, add it. That would give us what, 17? Positive 17, so negative 17, add it, we'd get positive 3, negative 3, we'd get 0. So now I end up with 9x cubed minus 33x squared plus 17x plus 3. Well, I still don't know how to deal with that, okay? But I have another root. So I just do the same process, the synthetic division again, and we can simply get it down to a point that we can deal with. So 27, so negative 6, negative 18, negative 1, negative 3, and 0. So we end up with 9x squared minus 6x minus 1. Which then, if we use the quadratic formula, okay, we'd have negative 6 plus or minus square root of negative 6 squared minus 4 times negative 1 times 9 over 2 times 9. So we'd have positive 6 plus or minus the square root of 36, right? 36, then plus 4 times 9 would give us 36 again. So 36 plus 36 would be 72 over 18. Okay, now 72, we don't know the square root of that, but we know it's 36 times 2, right? And we know the square root of 36 is 6. So we'd have 6 plus or minus 6 square roots of 2 over 18. 18 is like 3 times 6, so the 6's would eliminate, and we'd have 1 plus or minus the square root of 2 over 3, which, if you type it in your calculator, will give you this decimal and this decimal. Okay? And that's another way you can do it when they're more complex like that. Alright, but that's better than trying to guess at trying to do this process and then use that and do the synthetic division multiple times. Just much easier that way. Okay, now 9 and 10 want us to just go backwards. So remember, we have these as roots, and anytime you have an imaginary, you also have the opposite version of it. So I've got x plus 3 times x minus 2i times x plus 2i. So always start with your imaginaries, okay, two binomials. X squared minus 2ix, positive 2ix, and negative 4i squared. Those two cancel out, positive and negative. We end up with x squared. I squared is like negative 1, so plus 4 times x plus 3. Multiply it out one more time, and that'll give us our third degree polynomial. Okay, so we get x cubed, 4x, 3x squared, 12. So my answer here is x cubed plus 3x squared plus 4x plus 12. And that's my answer. Okay, for 10 we do the same idea. Okay, 4, and then with irrationals, you have the same thing going on. So I've got x minus 4, because we think opposite, x minus 3 minus square root of 2, and then x minus 3 plus square root of 2. So I'm going to multiply those ones first. This time we have 3. So x, negative 3, negative square root of 2, x, negative 3, square root of 2. So x squared, negative 3x, negative square root of 2x, negative 3x, positive 9, positive 3 square roots of 2, square root of 2x, negative 3 square roots of 2, and negative square root of 2 squared. Okay. So, when we look at this, positive and negative are the same, cancel out. Negative and positive cancel out. So x squared minus, combine those, 6x. And then whenever you square a square root, that cancels. So we'd end up with negative 2 when we multiplied those together. So 9 minus 2 would give us positive 7. Then we do it one more time, and we'll end up with our cubic function. So x cubed, negative 6x squared, 7x, negative 4x squared, 24x, and negative 28. So we get x cubed minus 10x squared plus 31x minus 28. And there's our answer. And there we go, guys.